Hi, in this video we have to solve this example with the help of application of the Rolle's theorem. So here how to use the Rolle's theorem to show this property. Here show that if a0, a1 up to an are the real number satisfying this condition, a0 by n plus 1 plus a1 by n plus a2 by n minus 1 plus dash up to an minus 1 by 2 plus an equal to 0. This is the given information. Then there exists at least one x, real number x, such that which belongs to the open interval 0 to 1 satisfying this condition, a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus dash up to an equal to 0. So here we have to show this, we have to prove this example with the help of Rolle's theorem. So here how to use the Rolle's theorem. So here I will write let f of x equal to let's say a0 by n plus 1 into x to the power n plus 1. Let's say this is my function, plus a1 by n x to the power n plus a2 by n minus 1 x to the power n minus 1 plus dash up to a n minus 1 by 2 x square plus a n x to the power a n x. So here this is a n x. Let's say this is my function f of x equal to, here this is let's say constant x a0 by n plus 1 x power n plus 1 a0 by n x power n a2 by n minus 1 x power n minus 1 and so on a minus 1 by 2 x square a n x. Let's say this is my function here, and so here the first condition of the Rolle's theorem. So here being an algebraic function, this function is continuous. Here let's say which is, here write which is defined on the closed interval 0 to 1. Here I am considering one function f of x equal to this which is defined on the closed interval 0 to 1. Now here, so here this function is continuous. So here being f of x is continuous on closed interval ab, being an algebraic function, being an algebraic function. So here first condition of the Rolle's theorem is satisfied. So here check the second condition of the Rolle's theorem, f dash of x equal to, here the f dash of x equal to derivative of first term, second term, third term, calculate the derivative. So here a0 by n plus 1 to the power here into x to the power n plus 1. Here I am first writing the constant n plus 1 into here, after that I am finding the derivative of this first term x to the power n, derivative of x to the power n plus 1 equal to into is the derivative of x to the power n plus 1 is n plus 1 into derivative of this n plus 1 into x to the power n plus 1 minus 1. So this is x to the power n here plus a 1 by n, here this is the n into x to the power n minus 1 plus a 2 by n minus 1, here n minus 1 into x to the power n minus 2, here plus and so on. Here I am writing plus a n minus 1 by 2, here 2 into derivative of x to the power 2 minus 1 is 1, here this is a n, derivative of x with respect to x is 1. So here this is equal to derivative of dash of x, this is equal to, here this n plus 1 gets cancelled, this n gets cancelled, this n minus 1 gets cancelled, this 2 and this 2 gets cancelled. Therefore a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dash up to, here this is a n minus 1 x plus this is a n. So this is my f dash of x. So this is my f dash of x. So here this means that f dash of x exists for all x belongs to the open interval 0 to 1. Therefore this means that f of x is differentiable on open interval 0 to 1. So here this second condition of the Rolle's theorem is also satisfied by this function. Now third condition of the Rolle's theorem says find the functional value at endpoint 0 and endpoint at endpoint 1. So f at 0 equal to 0. Here f of x is this. Therefore f of 0 is 0. Now find f of 1 equal to here a naught by n plus 1. Here x 1 to the power n plus 1 is 1 plus a 1 by n plus a 2 by n minus 1 plus dash up to a n minus 1 by 2 plus a n. Now here in the question this information in the question that is given a naught by n plus 1, a1 by n, a2 by n minus 1 plus a n minus 1 by 2 plus a n, which is equal to 0. Therefore f of 0 equal to f of 1. Therefore here f of x here satisfy all condition of Rolle's theorem. Here if f of x satisfy all the condition of Rolle's theorem, then there exists C belongs to the open interval 0 to 1 such that f dash of C equal to 0. So here f dash of C equal to 0, f dash of x is this one. Therefore f dash of C equal to 0 means a naught C power n plus a1 C power n minus 1 plus a2 C power n minus 2 plus dash up to here a n minus 1 C plus a n, which is equal to 0. So here this is the given. This implies that just a n. So here replace C by x. Therefore a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dash up to here again I am writing plus a n minus 1 x plus a n. So here that's we have to show. Therefore there exists x. So here which is equal to here there exists x belongs to the open interval 0 to 1 such that a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus a n equal to 0. That's we have to show, prove, hence proved. Hence the result proved. That's we have to show. Here how to use the Rolle's theorem. Here by using the Rolle's theorem we have to show this result. So thank you.